there's notions of domain and range, just like with functions. The domain of a relation is just the set of all the first coordinates of these ordered pairs. The image or the range is the set of all second coordinates of these ordered pairs. So just a quick bit of terminology there. And then you can take a moment and practice from hands-on exercise 7.1.4. What's the domain? What's the image? Remember, S had very specific ordered pairs. Not every possible ordered pair you can make from A and B will qualify to be part of S. So you have to be careful and use your answer from the hands-on exercise to be able to answer this question. Next, we're going to talk about ways to represent relations. There's a couple of useful ways to represent relations. And the one we're going to talk about now is called a digraph, which is short for directed graph. So all the elements of A and B are going to be represented by vertices or dots. And we're going to say that A is related to B if there's when I say A and B, I mean little a and little b. They're related to each other if there's a directed edge from A to B. In other words, what I'm seeing here is 1, 1 is an element of this relation. 2, 2, 3, 3, 4, 4. Let's see, 1, 3 is an element. So is 3, 1. 2, 4, and then let's see, there's 5, 3. So there's every directed edge is giving us a way to represent an ordered pair in this relation. Another way we can represent a relation is with a matrix. Okay, so we're going to use ones and zeros in this matrix. And so we're going to kind of label the rows of the matrix with elements of A, and we're going to label columns of the matrix with elements of B. And we put a 1 in that position if that A is related to that B. So it would be helpful to look at an example simultaneously. Okay, so they're making reference to example 7.1.6. Here it is. In 7.1.6, we had these ordered pairs. Writing ordered pairs, like a long list of ordered pairs, even for sets of size 6 and size 4, is kind of tedious. So instead of representing it this way, we could use the digraph representation we were just talking about, or we could use the matrix representation. Notice that the rows are labeled with elements of A, and the columns are labeled with elements of B. I'm going to just pick a random one in the matrix here. So this is in row 3, column 3. And so is it true that 3, 3 is an element? Yes. Okay. What about, let's see, this one? This one here is saying that 6, 2 is an element of the relation. Is that true? Yes, there it is. Okay, so we can use a matrix to represent a relation. Of course, only if the two sets are finite, because you don't want to deal with an infinitely sized matrix. So for practice with these matrices, these matrix representations, go ahead and return to hands-on exercise 7.1.4. You're still going to need those ordered pairs that you found when you worked on that hands-on exercise. And you're going to determine the incidence matrix for the relation S. Remember, A is related to B if A divides B. And one more hands-on exercise. This time it's going to relate to an earlier example where we had students and courses as the two sets that are being related with each other. So we have John, Mary, Paul, and Sally, and we have a bunch of courses. And so what we want to try to do is practice using a digraph and an incidence matrix to represent the relation R, which is A is related to B if student A is taking course B. So pause the video, give that a try, just for practicing these different ways of representing a relation. Okay. So what are the key things we talked about in this section? We haven't talked about functions in this course, but I do expect you to have seen functions in something like a pre-calc course, for example. And if you've taken calculus or linear algebra, you've definitely worked a lot with functions. Relations are kind of a generalization of that. It takes elements from the two sets A and B and gives ordered pairs as representations of how those elements in the ordered pair are related to each other. It's important to remember at its core, the formal definition of a relation is that it's a subset of A cross B, the Cartesian product of A and B. We talked about domain and image or range. You can use those interchangeably in this context. And we sometimes will use the name of the relation, the capital letter name of the relation, as a symbol joining the two elements, as another way of saying that the ordered pair belongs to that relation. And a few of the examples we talked about are these, and we didn't talk about subset, but that's a relation between sets. So if you're talking about sets of sets, you could even think of the subset symbol as a relation.